Okay, this is part of a module on matrices, and we've done first 5 or so of these bullets. We are now here to determinant. Let's get down to the determinants. Cover lots of stuff. Oops, there we go. The determinant. First, what is it? It's a number associated with a square matrix. It will come up useful later in the course in some of these other subjects. So I'm just going to get to how do you compute it. So we have a square matrix, say at 3 by 3. A looks like this. The determinant notation is, it looks like absolute value signs, just straight bars. When you see that, that means not the matrix, but the determinant of that matrix. So let's go through some determinants. First, if it's just a 1 by 1, a matrix with a single element, the determinant is the value of that single element. So this here doesn't mean the absolute value of -3. It means the determinant of the 1 by 1 matrix whose single element is -3. Its determinant is -3. You can't really tell unless you know the context. You don't know if this means absolute value or determinant. And actually, at least in my class, my courses, we virtually never did anything with 1 by 1 matrices. So that's almost a trivial case. For a 2 by 2, let's say this generic A matrix. There's the notation for it. It has a simple computation. It's the product of the main diagonal terms minus the product of the off diagonal terms. So like that. So if you had the matrix 1, 2, 3, 4, it would be 4 minus 6 or minus 2. Here's some other easy cases. This would be 28 minus 6, which is 22. 10 minus a minus or plus 6, so 16. This would be 12 minus 12 part squared. Get used to doing 2 by 2s because everything you do by hand will ultimately break down into 2 by 2 matrices. So that's what you'll be doing over and over again when you compute it yourself. To get the bigger matrices, we need to talk about minor determinants and cofactors. A minor determinant is the determinant of the matrix left after you remove a certain row and column. So say this the starting matrix. The 1, 1 minor determinant, M sub 1, 1, is the determinant of after you remove the 1, 1 term. That's row 1 and column 1. So remaining matrix would be 2 minus 1, 7 minus 4. Then do that determinant, which would be minus 8 plus 8, I guess. 0, I guess. The 1, 2 term. Get rid of the first row and the second column. It should be the remaining matrix should be 1 minus 1, 5 minus 4. Right. So minus 4, 5. Determinant. The 2, 3 term. Row 2, column 3. That would be 2, 6, 5, 7. So those are minor determinants. Cofactors are just minor determinants with the proper sign, either a plus or minus. And you could do it 2 ways. If you think of the cofactor as having C sub ij, is minus 1 to the I plus j times the minor determinant ij minor determinant. If I plus j is even, it's a plus. If I plus j is odd, it's a minus. Another way to think about it, 3 by 3 is what you'll be doing mostly by hand, is the signs go, they alternate as you go strictly right or left or strictly up and down, not diagonal. So here you go from plus to a minus, back to a plus, go down, we go plus to minus, go left, we go minus to plus, etc. Just alternate sign, go strictly up or down or right and left. I guess let's do a couple things here. I'll do the C11 and C12 term. C11. We remove the first column in the first row, so it's 2 minus 1, 7 minus 4. And 1 plus 1 is 2, so it's just a plus. The C12 term is the remove the first row and second column. It'd be 1 minus 1, 5 minus 4. 1 plus 2 is 3, that's odd. Or you can also think it's up here in this position, so we put a negative on it. A negative sign for that guy. So those are minor determinants and cofactors. They're almost the same thing except for the sign. So then how do you do determinants of 3 by 3? You expand it by cofactors. You expand it by a row or column of your choosing, and then use cofactors. So let's say we expand this guy by row 1. First element is 2. We'll have a 2 times the cofactor of the 1, 1 term, which will be 2 minus 1, 7 minus 4. And that's the plus place. Or it's the 1, 1 place, which 1 plus 1 is 2, and that's even. So the next one is, we're doing it expanding by the first row. So now we have a 6 times the cofactor, the 1, 2 cofactor. We get rid of the first row, second column. We have a 1 minus 1, 5 minus 4. But the sign there, that's a minus sign. Our 1 plus 2 is 3, that's odd. That's why we have that negative sign. And finally, add this guy's cofactor. It'll be 1, 2, 5, 7. That's a plus place. You know, if you go back here, that's a plus. Just keep this in your head, or you can do it on your own in your head. That's how you can keep track of signs. Now it's just arithmetic. You can do 2 by 2s, right? This will be minus 8 plus 7. Did I do that right before? I did this wrong before. Minus 8 plus 7, not plus 8. This will be minus 4 plus 5, right? This will be 7 minus 10. Anyway, you do all that arithmetic, you get 11. I can expand by any row or any column, your choice. Usually, if you don't have a good reason, you do it by the first row or the first column. So let's do it just to show you how it's done, like by column 2. We're expanding by column 2 here. So the first one will be a 6 times the cofactor of the 1, 2 term. 1 minus 1, 5 minus 4, a minus. 1 plus 2 is 3, that's odd, or that's the minus position. Plus 2 times its cofactor, which would be 2, 1, 5 minus 4. That's a plus, or 2 plus 2 is 4, that's even. Finally, plus 7. 2 minus 1, 1 minus 1, and that's a negative place. That's the 3, 2 term. 3 plus 2 is 5, that's odd. Go back here, it's a negative sign. That's how you do 3 by 3s. You break it down into 2 by 2s. You expand by a row or column. We could talk about minor determinants and cofactors of larger matrices. It's always based on the determinant of the matrix after you take out a row and column. So let's say we started with this matrix, and what's the 3, 3 minor determinant? O3, column 3, so the remaining matrix should be 0, 2, 0, 1, 2, 3, 1, 4, 2. We've got the third row in the third column. That's the minor determinant. Now we've got a 3 by 3 matrix to find a determinant of. Here's a nice thing. This top row has only one non-zero element, so you want to use the top row to expand this guy. It'll be 1, 3, 1, 2, and it's in the negative position, so there's all you got to do. You only have to do 1, 2 by 2 to do this guy. The answer there is 2. Let's say the 3, 4 cofactor. Let's see, row 3, column 4. What's left should be 0, 2, 4, 1, 2, minus 2, 1, 1, 1. Up there. And that's, let's see, here's the 3, 4 position. We've got plus, minus, plus, minus, plus, minus. And a minus sign. Bar 3 plus 4 is 7. That's odd. You need a minus sign. So now you need to find the determinant of this 3 by 3. I'm not going to go through that. I think I would expand by this first column, 0 in it, and then 1s. I'm not going to go through that. You can do larger than 3 by 3s by keep doing the same thing. You always expand by a row or column of your choice. But if you do a 4 by 4, the minor determinants are going to be 3 by 3s. And to do them, you got to break them down into 2 by 2s. So we generally don't do that. For example, a 5 by 5 matrix, you'd have to calculate 60 2 by 2 determinants. Generally, I never assign to my students a 4 by 4 matrix or larger unless there was some trick to it. But I never made them compute that many minor determinants. Follow the pattern so far. For bigger matrices, it's the same pattern. Here's one with a trick to it. It's a 4 by 4. It's got some ugly looking numbers in there. But if you notice the trick, do you see the trick here? You've got a column with only one non-zero term. So if you expand by this second column, it essentially becomes 3 by 3 problem. So you've got a plus, minus, plus. So I'll have the minus 3 because of this minus 3. Then the determinant of the matrix left after I take out that row and that column, which would be 2, 6, 1, 1, 2, minus 1, 5, 7. And we did this 3 by 3 before. It was minus 11, so that's the basics of how to compute the determinant. In another recording, we'll use properties of determinants to do some shortcuts to calculating them. That's the determinant.